It's gonna. Yeah, so that way I'll upload it afterwards, and in case anybody else wants to watch some of these problems. Yeah, because I didn't do 6 in my video, and I'd like to record that. So 6C. All right. Yeah, let's take a look at that one, and I'll just walk through it just to so that we can get a full solution here. So problem number 6. And so if somebody has a problem number 7, that would be nice as well. We can do that one next. So 6C is the one that you've asked for. Let's take a look. So the thing that we need to notice here on this one is it says find the missing coordinate for the point on the unit circle in the stated quadrant. So we can draw the unit circle. The unit circle is a circle that has a radius of 1. And here I'm gonna make 2 of these little increments be 1 unit. Just draw a circle. Just like that. And so this is in quadrant 1. So quadrant 1, we need it, hopefully we know the quadrants. It's that one there. And so you just pick any point here in quadrant 1. I'll pick, something like, right here. This is not perfectly to scale, but here's a point. It's x, the y coordinate is 1/4. So it really doesn't matter actually where we put the point. But I'm gonna put it right here just to be a little bit more accurate. The y value is 1/4, right? So it should be a quarter of the way up. And so once we found our point, we've located it in quadrant 1, we can then draw a line segment to the origin, and then a line segment to the x-axis. Now, which of these line segments do we know the length of? Do we know the length of any of these sides of this triangle? Here, I've drawn a right triangle. Can anybody tell me which side lengths do we know? And let's say this is the angle theta. We'll put that there.
The x.
So which ones do we know? The adjacent, the opposite, or the hypotenuse? And then this is for anybody, I guess. Anybody can feel free to answer.
I forgot what it's called, but it's the straight one. The one
that
Doesn't x go at the adjacent?
Yes, x goes in the adjacent side, and that one is unknown. So we'll put that there. Good. All right. And then the y coordinate is given to be 1/4. So I'll stick that in here. That is the length of this side here. That side of the triangle. I'll mark it in green here, right there. That is length 1/4. And what's the length of the hypotenuse?
1.
1. Very good. So that's the one that sometimes people forget. But in the problem, it does say we're on the unit circle. This circle has a radius of 1. So no matter where you draw that point from the center, from the origin to the circle, it's length 1. So now we have a right triangle. We know 2 of the side lengths. So we can use the Pythagorean theorem, which is x squared plus y squared equals r squared, and just plug in what we know. We know we don't know x. We know y is 1/4. R is equal to 1. And so we get x squared plus 1/16 equals 1. We're going to end up subtracting this 1/16 to try to solve for x. So I'll also multiply this 1. We know 1 is the same as 1/1. And so I can multiply it on the top and bottom by 16 to get 16/16. And so when I subtract, I get 16/16 minus 1/16. That's 15/16. And then we can take the square root of both sides. So x is equal to plus or minus 15/16. And so which of these two values do we choose, the positive or the negative?
Positive.
The positive? Why the positive?
Because we're in Q1, so the x values would be positive.
That's correct. Very good. Yeah, so notice, if you're in quadrant 1, you must be to the right of the y-axis. And so the negative one we can ignore. Positive 15/16 is the answer. Okay, so that is the missing coordinate. Does that help there? Anais, do you have a question on that?
No, it makes sense now. Thank you.
Okay, you're welcome. Let's see, and we've had a couple people join. So I will get to you, as we kind of cycle around the people. Let's see, and actually, I want to ask, does anybody have any questions about number 7? Does anybody want to see a part of number 7?
I was gonna say 7A.
7A? Sure. Yeah, so yeah, let's take a look at 7A. And actually, just to kind of have an idea of which questions are coming up, let me jump around here real quick and just ask everybody, but I won't, I'll do it after 7A, but let's see. Ashley, did you have another question that you were wanting to ask?
Let me see. No, you could do 7A first.
Okay. All right. Yeah, let's take a look at 7A and then we'll kind of cycle around everybody. Yeah, so we've got a good number of people here, so might take a little while to get around. But this is a good problem here. This one will actually practice a lot of the things that we need to know for other problems. So let's try 7A. Okay, so this was very similar to the one we just did, actually, except we're not really told at this point, or that there's a point on the unit circle. So let's draw a picture with the information that we're given. Okay. We're told that we are in quadrant 2, so we'll go over to quadrant 2, and we're given the sine of theta. The sine of theta is, remember, opposite over hypotenuse, or if you want, y over r, and that was given to be 4/5. So if I draw an angle that terminates in the second quadrant, then I can draw a triangle using, just a perpendicular line to the x-axis. And those side lengths, the side lengths that we know are the opposite side and the hypotenuse. And so more than likely, we're going to have to find the adjacent side length. And we can actually look ahead if we want to and say, okay, well, we're asked to find the tangent of theta. And remember that the tangent of theta is equal to opposite over adjacent. Okay, so there's no way to wiggle out of this. We have to find the adjacent side length. So here we'll use the Pythagorean theorem again. And I'm going to call this side length x just to make it nice and easy. X squared plus y squared equals r squared. Notice r is not equal to 1 anymore because nothing was stated about the unit circle here. And so just doing a little bit of squaring, a little bit of subtraction, and then a square root. X is equal to plus or minus 3. Now, which of those two values of x do we want? The positive x or the positive 3 or the negative 3?
Negative.
Yes, in this case we do want the negative one because now we're in quadrant 2, which has values of x that are negative. Any point in quadrant 2, choose any point over here in quadrant 2, its x value is negative and its y value would be positive. We're finding the x value, so we know that it's going to be negative 3. Okay, so oops, and that's not the answer. That's just the x value, the adjacent side length. And so, oops, and actually, yeah, I should be careful there. It's, yeah, the x value there is negative 3. So, tangent being opposite over adjacent, or y over x. Now we just set it up. Y over x is negative 4/3. And then secant is the reciprocal of cosine, so that's r over x, which is r, we said we were given that it's 5 over x, which we found to be negative 3. So those are our answers there. All right, so that was number 7A. Does anybody have any questions on that?
I was wondering, how did you know that it would be in quadrant 2.
That was given. That was given to us in the problem there. If we
Oh, okay.
yeah. It tells us that theta, yeah, is in quadrant 2. Yeah, and so technically, I've actually been a little bit loose on how I speak, how I say this, but the angle is this one here, technically. Theta, yeah, so theta is this angle that rotates from 0 to quadrant 2, but then we can actually just use the reference angle, and I'll just put a little subscriptive r in there. Yeah, so theta is in quadrant 2. The angle terminates in quadrant 2, and then using that terminating side that I've drawn, right here, we can use that to draw a little triangle to reference. All right, good. Any other questions there with problem number 7?
I had another question. So, when you put since it's 4 over -3, do you have to put the negative in front of the 3, or can you just put it where the fraction, like the line?
You can put it in either of these locations here. These should all be marked correct. I don't think you're my student, but by looking at your name, I don't recognize it. But I would mark any of these values correct because they're all equivalent. Yeah, and your instructor should too. Yeah. So yeah. So to answer your question is yes, this one's correct. Also, if you put that in on Alex, that would also be marked correct. All 3 of these are equivalent. Yeah. Good question there. Yeah, just when you put the negative, it is a little bit misleading. If you write it like this, kind of looks like the 4 is negative there, but not. No, I mean when there's a negative in a fraction, it applies to the entire fraction. So, yeah, either one of any of those 3 are correct. All right. Any other questions there on problem number 7? Okay. And then since we're actually almost done here with the problems in order, does anybody have any questions on number 8 that you'd like to see, or does anybody want to see number 8? Any part of
Yes, please.
Okay, yeah, which part of number 8 would you
I was actually interested mostly in B.
be? Okay. Yeah, let's take a look at B then, just to kind of talk through some of this stuff. And then oops. Okay. So let's see what this says here. B. Find C, A, and B. Okay, so I'll just kind of go over the nicest way to do this problem. Well, and I can open it up, I guess, in case we have questions, but let's start by finding one of the angles. Angle A. So far we only have 2 things that are given to us with respect to angle A, and that is the opposite side length and the adjacent side length. I just pointed both of those out. And so since we have opposite and adjacent, what trig function is used to relate an angle to its opposite and adjacent sides? Which trig
Is
function?
it cotangent?
Cotangent is one of them, yes. The cotangent of theta is equal to adjacent over opposite. The tangent is another one. The tangent of theta is the reciprocal, opposite over adjacent. So you can use either one of these. Now, I would, recommend that you look at both of these to see which one is easier to do, because let's take a look at the cotangent. Let's actually apply it to this problem here. I'll change the color. The cotangent of A is equal to adjacent 7 over 10. This one here is going to be the easiest one to do, because can you tell me what 7 divided by 10 is pretty quickly?
0.7.
Yeah, that's 0.7. And so all we need to do now is find some angle whose cotangent is 0.7. And so if we look at the cotangent column and we see 0.7 there, it tells us what angle. That's 55 degrees. The table tells us that the cotangent of 55 is equal to 0.7. So that means that A must be 55 degrees. So I do just want to comment here. I'll write it in red because this is not really what I recommend. If you had used the tangent, then we would have done opposite over adjacent. And then it's a lot harder to tell what 10 over 7 is. You could do long division and do it that way. It's not like it's impossible to do it this way. You can do it this way. It's just a little bit harder. So I'll leave you to take a look at that if you want to. So we found A. How do we find B? Angle B.
Since we know, wait, which one is it, capital or the lowercase?
Capital B. How do we find capital B?
Oh, okay. So for that one, since we solve for RA, which is 55 degrees, do we do like 90 minus 55?
Yes. So there is a property, and actually I'll write it down here. The three angles in a triangle add up to 180 degrees. And the property that Dolfo is mentioning is in a right triangle, you're guaranteed that one of them is 90 degrees. So if we just subtract 90 degrees on both sides, then that will tell us that the other two angles, the non-right angles, must add up to 90 degrees. And I think that's what Dolfo was mentioning. Let's see. Okay. And so we know A is 55. We figured that out just a moment ago. And so we can subtract 55 from 90. So that's good. That works. That works for us. And I think this is 35 degrees. All right, so cool. We found A and B. And now all we have to do is find C, little c, the side length C. So are there any suggestions for how we could find little c?
Can we do hypo divided by opposite?
Okay, the hypotenuse and the opposite sides?
Yeah.
Yes, and which angle do we want to use?
Can we do sec?
No, sorry. Which angle do we want to use? Angle A or angle B? We can use either one.
Sorry, what was the question?
Which angle do we want to use? Angle A or angle B?
Can we do angle B?
Sure. Yep. Angle B. So if we look at angle B, we want to find the hypotenuse. So we have to include the hypotenuse. But now we have, the adjacent side for B, right? So we need to find a trig function that uses the adjacent and the hypotenuse. So what trig function could we use?
Cosines?
Sure. The cosine of angle B is equal to adjacent over hypotenuse. The hypotenuse has length C. And so we get that equation there. And then we solve for C, solve for C by multiplying by C. So we cancel there. And so we get C times the cosine of B, equals 10. And then we divide by the cosine of B. And I just realized that I'm writing the cosine of B, but we know what we know what B is, so I'll plug it into the next step. So here we would cancel, and we get C equals 10 divided by the cosine of B was 35 degrees. So let's write that there. And so C is equal to 10 divided by, what's the cosine of 35 degrees according to the table?
0.90?
0.
Wait, isn't it 0.80?
Yes, 0.80. Good. And so what we can do is we can move the decimal place over one place to the right, and this decimal place over one place to the right. So this is the same as 100 over 8. And then all we have to do is figure out what 100 divided by 8 is. So you got to go back to your long division. 8 goes into 10 one time. 1 times 8 is 8. 10 minus 8 is 2. Bring down the 0. 8 goes into 20 2 times. 2 times 8 is 16. And we subtract. That's 4. Put a decimal place and bring down that. 8 goes into 40 5 times, and we're done. So I got C equals 12.5. Does anybody have the answers available? Is it 12.5 or C?
It's 12.0.
12.0. Yeah, and so as it says there and it's highlighted there, yeah, I just wanted to check because I was pretty sure that was going to be different. Yeah, answers can vary slightly, so this would be accepted. This is an acceptable answer.
I had a
This-
question. Sorry.
Yes. Uh-huh.
Did you use 10 and C? The 10
Yes.
inches and would that be sine?
Ah, would it be sine?
Mm-hmm. Because you use cosine.
Yes, I did use cosine.
Oh,
So you
mm-hmm. Sorry.
no, that's okay. Notice that we used angle B though,
Okay.
right? So what side length is 10 with respect to angle B? That is not the opposite of angle B. The opposite of angle B is 7.
Oh, okay.
So yes, if you wanted to use sine and these same two values, you could use angle A, and so I'll write it down here. The sine of A is equal to opposite over hypotenuse. You could use this equation as well, and you would get a similar answer. But since I think I asked, which angle, yeah, I asked that earlier, and Dolfo said angle B. So we went with angle B, and that made us essentially have to use cosine or secant.
Okay, that makes sense. Thank you.
Yeah. And so there's a bunch of ways you could do this. And actually, using the secant would have even been easier. I think Dolfo, you mentioned secant earlier, but I think you might have, you said it earlier before I even asked which trig function. I was asking a different question. So we ended up going with cosine. But secant would work as well with angle B, or sine with angle A, or cosecant with angle A as well. Cosecant, and I think that was Anais asking that. Cosecant would actually be better than sine because, and I can show you, might as well just do it real quick because it really just takes like one step. We'd multiply by 10. And what is A again? A was 55 degrees. So what's the cosecant of 55 degrees according to this chart? 1.2. And so that's 10 times 1.20. And C is equal to 12. Notice how easy that was. If you choose the correct trig function, or by correct I mean like the one that's easiest to solve, you can save yourself a little bit of time there. Yeah, it took us like a few seconds, whereas the other one had some long division and other stuff to do. All right, cool. Yeah. Does anybody have any questions, just since we've been going in this direction with number 9? Does anybody want to see a part of number 9?
Thank you.
Yeah.
Yeah, you're welcome.
Number 9A.
Yes.
9A? Okay, sure. Yeah, and then this is the last one here that I'll do, and then I'll go back to asking people for their specific questions. But I know I'm sure you've worked on these already a little bit, so we can yeah, just kind of jump around a little bit. All right, so 9A. Angela is standing on a tower at a height of 200 meters. So here's the tower, 200 meters tall. Here is Angela. She notices a car accident some distance from the tower. Okay, so the car accident is some distance from the tower. If the angle of depression from Angela's eyes is 35 degrees, how far is the accident from the base of the tower? So let's draw the line of sight here, to this accident. And so we get a right triangle here. But then we're told the angle of depression is 35 degrees. So when we talk about the angle of depression, we're talking about from the horizontal. So imagine Angela looking in this direction. And then how far the angle of depression is how far she would have to tilt her eyes. This angle is 35 degrees, or tilt her head, I guess, downward 35 degrees from the horizontal to see the accident. So we could actually draw a new triangle, another triangle. And so hopefully you can see it there in red. I'll just fill it in a little bit. There. And we know the height of this triangle is also 200 meters. That's just the same as the height of the tower. And then what do we want to find? We want to find how far is the accident from the base of the tower. Uh-oh. And so we're trying to find this distance here, which is x. And so which trig function can we use to try to solve this?
I was wondering, you know how you have like the 0 or the sign equals 35? Can we do that like with the car as well? Like 35 degrees on the other one?
Yes, we can. Yeah, if you wanted to, you can. It is true also that theta over here is equal to 35 degrees. Yeah, there's a property in geometry that tells us that those two are equal. So in either case, though, which trig function do we use to solve this? Yeah, and I see in the chat, Connor saying, yeah, we have the opposite side and we have the adjacent side. So tangent of 35 degrees could work. That's opposite over adjacent. So that would work. Yes, we could use that. There's actually, I'll say, another function that we could use that would actually require less work. What's the other function that we could use to solve this?
Can it be cotangent as well?
Yes. Cotangent would work also. The cotangent of 35 degrees, that's equal to not opposite over adjacent, but adjacent over opposite. And so that would be adjacent over opposite. That right there. And so this is actually a little bit cleaner because if we, to solve for x, all we have to do is multiply by 200. And then we get 200 times cotangent of 35. That should be on here somewhere. Cotangent of 35 is 1.45. And so this is equal to, you can multiply that out. 200, it's 2 times 100. So multiplying by 100 moves the decimal place over 2 places. So this is the same as 2 times 145, or 290. Okay, so we would say the base of the tower is 290 meters from the accident. Okay. Okay. Any questions there?
I have a question. I was gonna say, like solve for the x. Couldn't we also use opposite divided by Oh wait, never mind. Never mind. My bad.
Yeah, were you thinking opposite over adjacent?
Yeah, I was thinking about like opposite divided by adjacent. Does that also equal like tan and cotan as well?
Yeah, so you can use that. Yeah, and so we mentioned that this will work also. It just requires more work.
Yeah, long division.
Yeah, so it'll work though. I mean, yeah, don't if that's the one you come up with, let's say this is on your quiz, you know, it'll still work. Yeah. Because
Okay.
it's still using the correct sides. The one that you know, 200, and the one that you don't know, X. Yeah, you wouldn't be able to really use sine here, or at least not as easily, because sine involves the hypotenuse, and we don't have the hypotenuse in this case.
Oh, and yeah, I was gonna say that the will it be just like like number 8 as well as like you get a different answer and you know like cotangent you got 290 but in tan you got a different answer, you know.
Yes,
Does
yes,
that like also work will also work on that worksheet too?
yes. The answers may vary on this problem as well.
Okay.
Yeah, it does say that right there in the problem there.
All right.
All right, cool. So I'll open it up to questions. If anybody has another question and wants to speak up, we've kind of gone on through problems 6, 7, 8, and 9. So I'll just open it up here. If somebody has a question on another problem, just feel free to speak up, and we'll do that one next.
I was sorry to interrupt. I was very curious for number 3, wasn't it? I was very curious on that one.
All right. Would you like to take a look at 3B
Yes, please.
or 3? Okay. Yeah. I did 3 earlier when we could go over it again, and that's fine. But 3B, you know, is pretty much is very similar. So let's take a look at that. Well, so we're asked to find the cosine of theta. The cosine is adjacent over hypotenuse. We know the hypotenuse length, that's equal to 5. We know the opposite side length, that's equal to 3. We need the adjacent one. And so we can also just call it x for right now, since it's unknown. The opposite one we can call y, and then the hypotenuse we can call r. So using the Pythagorean theorem, we can solve for x. So x squared is unknown, y is 3, so we'll square that, and then r is 5. So x squared plus 9 equals 25. If we subtract 9 on both sides, x squared equals 16. And then if we take the square root,
4.
yeah, we get 4. Now, in this case here, officially I should put plus or minus 4, but we are only considering the positive ones, because here we're talking about the lengths of sides of a triangle, and we're not told like this is in quadrant whatever. So the length of a side of a triangle is always positive. So it's we'll choose 4 as our x value. And so adjacent over hypotenuse is 4 over 5. Cosecant is hypotenuse over opposite. So that is 5 over 3. And cotangent is that's not opposite over adjacent, right? That's adjacent over opposite. And so adjacent
4
over
divided by 3.
opposite. Yeah. And then those are the 3 values we're looking for. So problem number 3 really just comes down to finding the unknown side length, and then just constructing the cosine, sine, tangent, or whatever, you know, whatever you're asked of using SOHCAHTOA. All right, so let's see. Yeah, maybe we'll go in back in order here. So I'll go to Anais and see, do you have another question you'd like to ask?
Right now, no questions.
Okay, that's fine. How about Ashley? Any questions from you?
No.
Okay. And then we can go to Christian. Do you have a question you'd like to ask right now? All right. You can ask Connor. What about Connor?
Okay, so I wanted to go over number 5 if we can.
Mm-hmm. Sure.
I believe we went through 6 through 9, correct?
Say again.
We went through 6 through 9, right? Just right
Yeah,
now.
yeah. I mean, since we started, I think somebody's asked a question on problem 6, 7, 8, and 9. Yeah. So yeah. And then I mentioned I'm recording this, so I'll post it up a little later after office hours are over. Yeah, so you said 5. Which is there a specific part of number 5, or do you want me to?
Yeah, sure. Can we go over 5F, please?
5F, sure. That's a good one. Now, I will ask you, if you have like any specific way maybe that you've tried this problem, or because there are so many ways to do this problem, if you could guide me in some direction, or I can just pick, whatever way I think, it's just, if you've already tried a certain way, we can continue in that direction, or we can just start from scratch and yeah, whatever you want.
Honestly, I'll go from scratch. Whatever works for you.
Okay, sure. Yeah, so let me say this here. So let's take a look at an example, actually. I'll do that. Yeah, so the tangent, or let's say the sine of 30 degrees is equal to the sine of any coterminal angle with 30 degrees. So a 30-degree angle is, I'll just draw it here, is, something like this. This rotation here, that's 30 degrees, let's say approximately. But I could also rotate and go around to 390 degrees, meaning 30 degrees plus 360 degrees more. So 390 degrees. And the sine of both of these angles would be equal. And so this is just the sine of 30 degrees plus 360. And so this property here, the fact that the sine of two coterminal angles is equal, is what we're going to use to do this problem. So these are coterminal, meaning they terminate in the same place. And so negative 300 degrees, tangent of negative 300 degrees, negative 300 is not on the unit circle, because the unit circle has the values from 0 degrees to 360 degrees. So we can find a coterminal angle with negative 300 by adding 360 degrees to 300. So I will add 360 degrees, because notice 360 degrees is just one rotation, right? So wherever that angle is, negative 300, rotating 360 degrees is going to still have it terminate in the same direction. So I'll add 360 degrees, and you can see negative 300 plus 360 gives us a 60-degree angle. So using the property that we said before, the fact that the tangent of negative 300 is what we're looking for, we can actually just then find the tangent of 60 degrees, because these are coterminal angles. And 60 is on the unit circle. Now, can somebody tell me, tangent is the ratio of which two sides in terms of, X, Y, and R? Or even in terms of SOHCAHTOA, I guess, but.
The opposite over the adjacent sides.
Yeah, so tangent is of theta is equal to opposite over adjacent. And if you look at a triangle in quadrant 1, the opposite side and the adjacent are sometimes called y and x. Why? Because the opposite side is in the y direction, up and down. The adjacent side is along the x-axis, to the left and to the right. And then the hypotenuse is sometimes called r. So we also have to kind of memorize this as well. And if you're in my class, we talked about it. So opposite over adjacent can also be written as y over x. And the reason that we want to do it, write it as y over x, is because when we go search 60 degrees on the unit circle, can somebody actually tell me the associated point with 60 degrees on the unit circle? Well, actually, I'll scroll over just in case anybody's wondering what it is. So we go over to the unit circle. And let me delete some of this stuff here. Did anybody find it, the associated point? It is this one right here. 1/2 square root 3 over 2. And this is an x and a y coordinate. And so this x and y are going to be used to find tangent. So 1/2 square root 3 over 2. Let me see here. 1/2 square root 3 over 2. And so y over x is this. And then I can just do a little bit of division here. The square root of 3 over 2 divided by 1/2 is the same thing as multiplied by its reciprocal, and the 2's cancel, so we get the square root of 3 over 1, or the square root of 3. That's what we get there. Yeah. All right, so is that okay there, Connor, or did you have any questions about that?
Yeah, so just basically like from my understanding, like for number 5, so if we're looking at, like C, we're
Mhm.
just kind of like adding or subtracting that 360, right? To kind of find the equivalent coterminal angle, right?
Yes, if you need to. For part C, you don't need to do that because 150 degrees is between 0 and 360.
Oh, right. Okay.
So that one's
means
actually,
you can already find the equivalent of
yeah,
it.
yeah, you don't have to do any of that work. You can actually do it just by going over here, finding 150, which is, right here, and then cosecant of 150, just to show, how different some of these problems, some of these are a lot easier. The cosecant is, what is that one? Opposite of, the reciprocal of sine. So that's r over y. And so that would be r, the radius of the circle is 1, and y is 1/2. So 1 divided by 1/2 is 1 times 2 over 1, which is 2. So notice that one was a lot less work. The answer is 2 there, because that angle was already on the unit circle. Or so yeah, it's already between 0 and 360 degrees.
Okay.
Now, yeah, one other thing I'll mention, like I said, there's a lot of ways to do this problem. So if you're very good with angles, you could have actually shortened the problem from before too, just a little bit, by saying, okay, well, we were looking for the tangent of negative 300 degrees. Well, if we start here at 0, and then we rotate in the negative direction, this is negative 270 degrees here. Right, 3 quadrants is 270 degrees, and so all we need to do is go 30 degrees more to get to 300. And so, we could have actually gotten here without even doing any calculation really, or much calculation, just rotating in the negative direction, negative 90, negative 180, negative 270, and then we need 30 more, in the negative direction to get to negative 300. Notice we get to the exact same spot here, and then we do y over x, and we get square root of 3. So just depending on, your comfort level with some of these angles and ideas, there's a bunch of ways, that we could do that. All right, so we'll move on here. We'll go to Dolfo next. Did you have another question you'd like to ask about?
Yeah, I have a question for number 2 again, for A, because confused a little bit about it, about the
Two,
problem.
2,
Oh, no, sorry, not 3A. My bad.
3A. Okay. Uh-huh.
Yeah.
Yes.
I was confused about that one.
Okay. Is there any specific part that you were confused about?
Um, like mostly at the beginning, and then all I know is like there's like a square root that I just see there. So I was confused. Like, how did you solve the square root?
Yeah, okay. So yeah, so uh for this one here, you have to find the unknown side length. So we can call it y. And so we're going to do that using the Pythagorean theorem. So x squared plus y squared equals r squared. So that's 16 plus y squared equals 36. If we subtract 16 on both sides, then we get y squared equals 20. And then if we take the square root to solve for y, then we get y equals plus or minus. Yeah, I'll just write it as plus or minus. Now, yeah, we can actually simplify this. I believe on Alex, there was some work that you had to do that had to do with simplifying square roots. So with simplifying a square root, you can break it up into, since 20 is 4 times 5, you can actually break this up into the square root of 4 and the square root of 5. And the reason we want to do this is because we know what the square root of 4 is. The square root of 4 is 2. And the square root of 5, we can't get a nice answer for. So, so we've simplified that square root there, and we only want the positive one, so we'll just write it as y equals 2 square root of 5. And once we know that, then the rest of it is, just SOHCAHTOA, or, looking at the sine tangent. Or actually, yeah, I mean, we can write these, since this is on a triangle, we can call these the opposite, adjacent, and hypotenuse. And go from there. Is there a specific one of these trig functions that you want to see?
I'll want to solve for like the sine, the sec, and the tan if we can.
Okay, yeah, so sine is opposite over hypotenuse. And so the opposite side length is 2 square root 5, that's the one we found, divided by the hypotenuse, which is 6. And then we can divide by a factor of 2. If we divide by a factor of 2, we get 1 on top and a 3 on the bottom. And so the answer to the sine one, which I'll write in green, is the square root of 5 over 3. And let's see. So is that one okay there?
Oh yes, okay. I was gonna ask a question. How come the one is not there? And can we just have one square root of 5 divided by 3, or just square root 5 divided by 3?
Sure, yeah, you can put the 1. Yeah, you can even put a 1 right here if you want. 1 times 3.
Okay.
Yeah. I mean, if you want to, because yeah, remember 1 times anything is just itself. So, you can knock yourself out there and put up as many 1s as you want. Because yeah, whenever you write any number, it's you can write it as itself multiplied by 1. But yeah, so you don't have to write that 1 there. But you can. Yeah, I don't think that does any harm. Just like when you write x plus 5x, what's the coefficient here?
Isn't it just 1?
Yeah, so you could write it or not. It's understood that it's 1, that there's a 1 there if you don't put it.
Oh, okay.
So
Okay.
yeah, whatever you like there, that works too.
Oh, I see. And I was wondering if we could do like sec too.
Okay. Yeah, so the secant of theta
Is the cosine.
is
Like
1 over cosine, yeah. So it's 1 over the adjacent over hypotenuse. And so that's the same thing as just hypotenuse over adjacent. And so if we look at the triangle, hypotenuse is 6, adjacent is 4. And so reducing by 2, we get 3 over 2. And then
Okay.
finally, tangent is TOA opposite over adjacent, or if you want y over x. So that's opposite over adjacent. And we can cancel out a factor of
5.
2, and what do we get?
Isn't it square root of 5 divided by 2?
Do we need a 1 here at the front? Oh,
Yeah.
yeah, we can put it. We don't need it. Yeah, we don't need it, but we can, we can.
I see.
Yeah, all right. Yeah, Ashley, do you have a question? I saw a little hand there. I don't know if that.
Yes, I do have a question.
Oh, yes.
Okay. If it's my turn.
Oh, yeah, sure. Well, I called on Ashley, but you can go too.
Oh.
Yes, no, go ahead.
Oh no, this is Ashley.
Oh, sorry. Oops. Okay, sorry about that. Your voices are similar.
I mean, like it's Ashley's like profile.
Okay. Yes.
Okay. So can we do 5E?
5E. Yes, we can. 5E. Sure. Yeah, and so we did 5F a few moments ago. So we're going to do something very similar for 5E. So did you see 5F that we did, a couple minutes ago?
Yeah, I get it. Like I get the whole process of like using like the graph to like graph the triangle, but like I don't know how to like find 29 pi like on the unit circle.
Yes.
All that.
Yeah, so 29 pi over 6 is not on the unit circle, but we can find a coterminal angle, an angle that is coterminal with 29 pi over 6 that is on the unit circle. And we can take the secant of that angle. So yeah, let's do that. So let's see, maybe I can squeeze it here into this corner, so that we don't, so that we can see the solution of the other one as well. Okay, so let's see here. 29 pi over 6. And as I mentioned, let's see, 29 pi over 6. Yeah, so the values on the unit circle are those that are from 0 to 360 degrees, or if we're working in radians, 0 radians to 2 pi radians, right? Because those are equivalent. So the question is 29 pi over 6 inside of this interval from 0 to 2 pi? And well, if you already looked at the unit circle and it's not there, then probably not. No, it's not. It's actually very large. It's larger than 2 pi. And one way that you can determine how that it's not in from 0 to 2 pi is to divide these coefficients. Can you tell me how many times does 6 go into 29?
4?
4 times. Yeah, so this is actually around 4 pi, because 29 divided by 6 is 4, and there would be a remainder of 5. 4 and 5, 6 pi actually. And so it's basically it's larger than 2 pi. So what we should do is subtract 2 pi from this to try to find an angle between 0 and 2 pi. And so if we subtract 2 pi, well, that's the same thing as subtracting 2 pi over 1. Well, in order to subtract this, since they're fractions, we're going to have to get a common denominator. And so this is the same as 29 pi over 6 minus 12 pi over 6. And so if we subtract that, that is, what do we get there? This would be equal to 29 minus 12 is 17 pi over 6. Now, how many times does 6 go into 17?
2?
2 times, and there's still a remainder. So again, we're still over 2 pi. So we should subtract 2 pi again. Now, to skip the step of getting a common denominator, instead of subtracting 2 pi, I'm going to write it as 12 pi over 6. Getting a common denominator, multiplying the top and bottom by 6. And so what does that get us? That is
5 pi over 6?
Yes, is this 5 pi over 6? Actually, now, how many times does 6 go into 5?
0.
0 times. So now we're within 0 and 2 pi. Can we find 5 pi over 6 on the unit circle?
Yes.
Yes. And what is the associated point with 5 pi over 6?
Negative square root 3 over 2 and 1 over 4.
Yes, very good. So let me write that one down. Negative square root 3 over 2. Where am I here? So the associated point is negative square root 3 over 2, comma 1/2. And we are looking for the secant. My iPad is kind of being a little weird. Secant of 29 pi over 6. And that is the same as the secant of 17 pi over 6. And that is the same as the secant of 5 pi over 6. 5 pi over 6 is the one that we were able to find on the unit circle. So the secant, remember we said earlier, I think is hypotenuse over adjacent, or r over y. Sorry, r over x. And so r, what is the value of r on the unit circle?
1.
1. So 1 over the x value, negative root 3 over 2. So that is, we'll flip the bottom. So 1 times a negative 2 over root 3. We should rationalize this. I believe that's what we want for the answer. So multiply by the square root of 3 on top and bottom. And so we get negative, excuse me, right, negative 2 root 3 over 3. Oops, my computer is acting funny. Over 3. And so this is our answer. Yeah, does that help?
Yeah, that helps. Could you leave it like that, like just for a second so I can like
Yeah.
copy it?
Yeah. And then in the meantime, while you copy that, I will mention one other thing, but I kind of don't even want to say this because I don't want this to be used, you know, when it shouldn't be. But I'll mention it anyways, just because it's useful. Notice that earlier I said 29 pi over 6, and I said, is this between 0 and 2 pi? You can divide 6 into 29 to see that it's not. If we divided 6 into 29, you said that was it went into it 4 times, and there was actually a remainder of it was 4 times with a remainder of 5. So we can write 29 over 6 as 4 and 5/6 times pi. And so if you remember what mixed numbers mean, 4 and 5/6 is really 4 plus 5/6 pi. And then 4 pi, if I distribute the pi now, 4 pi plus 5 over 6 pi can be thought of as, well, 4 pi is the same as 2 pi plus 2 pi plus 5/6 pi. And these really can be ignored because they're full rotations. So the angle that we're really considering, or the coterminal angle, is 5/6 pi. So that's another way to get to it. And it can be done very easily if you divide 6 into 29, that's 4, and then with the remainder of 5, that gives us a 5/6, and then knowing that 4 pi is the same as not rotating really, or yeah, the 4 pi can be ignored, and so we're left with a 5/6. So a couple ways of doing that there. The only, yeah, there's some potential to make a little mistake there with that method though, so that's why I kind of didn't want to mention it, but I thought I'd just put it out there just in case.
Thank you.
Okay, yeah, you're welcome. All right. Does anybody else have a question? Let's see, I can go down the list. Christian, did you have another question that you'd like to ask, or?
Yes, I had a question on, let me see, 6D, if you hadn't done that one already.
6D, let's take a look. 6D. No, yeah, we haven't done that one. So yeah, let's take a look at that. So the way that I told, and whose discussion are you in, Christian?
Mr. Mua.
Okay, cool. Yeah, so so this could be a little different than what was mentioned in your class. I'm not sure. There are many ways to do these problems, but this is a valid way, so you can use this. It might be a little different. So maybe I'll ask you a little bit too about how you would do this problem, but or yeah, I can work through it, and then you can tell me if you do it a different way, we can discuss that as well. So 6D, we start by noticing that we're told that we are on the unit circle. So I draw the unit circle. The unit circle is a circle with radius 1. I've already drawn it here. And then it says that there is a point in quadrant 3. So quadrant 3 is this one over here. So there's a point somewhere in here. I'll just draw it right here. It doesn't really matter exactly where you draw it, as long as it's in quadrant 3. I could have drawn it over here, not a huge difference. And once I draw that point on the unit circle in quadrant 3, I can then draw a triangle by drawing a little side line segment to the origin, and then another line segment to the x-axis. If I go straight to the x-axis, then I will have a perpendicular, little joining there, a 90-degree angle. And so now I have a triangle, a right triangle, and I know a couple of these side lengths. Which side lengths do I know? Well, I was given an x and a y coordinate, and so the y coordinate is one that I know, and it's negative square root 5 over 4. So I will stick that in here. Negative root 5 over 4. And notice, we should be pretty confident, that, well, hopefully that we're doing this right. The y value in quadrant 3 is going in the downward direction, so it should be negative. So that kind of matches up there. Now, the other value that we know is this hypotenuse length. Can you tell me what the hypotenuse length is, Christian?
Is it, let me see.
And it's a little hidden, but it is given. The length of the hypotenuse is 1. Because we are on the unit circle. And if you take a look at this line segment, it goes from the center of the circle to the edge of the circle. And so this is just the radius of the circle.
How did you know that negative square root over 4 would be in the opposite, and 1 would be for hypotenuse?
Well, okay, so let's start with the negative square root of 5 over 4. That one is essentially given in the problem here. Notice it's in the second coordinate, right? This is a point that's given here, right? And any point that you're given is an x and a y coordinate. And so since the second coordinate was given, that's the y coordinate. And so if we take a look at this point here, the coordinates of this point are x comma negative square root 5 over 4. And so so how do we plot this point? It's just like if I asked you, how do you plot this point? Say I asked you to plot the point 1 comma negative 5. How would you plot this point on the axis? I assume you would say go to the right 1 unit and then down 5 units, right? To
Yes.
plot 1 negative 5. And so yeah, okay, so to plot, how do we plot x comma negative square root of 5 over 4? And we're told this is in quadrant 3, so we go over some amount, some x number of units, and then down square root of 5 over 4 units. And so that's how I know that that opposite side length, the one that's going down, is square root of 5 over 4. in length. Okay, does that make sense for the square root of 5 over 4?
A little bit, because I felt that, or I thought that it could be also be put in the adjacent side too.
Yeah, and again, this could be a little bit a difference in how we are approaching this problem. Maybe, your instructor might have done it a different way, because there are different ways to do this. But if I just ask you, to let's say we kind of change this up, because the square root of 5 or 4 might be kind of throwing things off a little bit. If I told you to, let's see. Yeah, but it really could not go on the adjacent side, because yeah, if let me start from scratch over here and just say, okay, I'm asked to plot this point, x comma -5 over 4 in quadrant 3. Okay, well, quadrant 3 is over here. So I can plot a point, let's just pick this point here, and let's assume that that's, its coordinates are some x value and negative square root of 5 over 4. Got my square root over here. Yeah, well, this y value here is negative square root 5 over 4. And then if you draw a line to the origin, then this length here would be x. I guess one way that you could get it in the adjacent side, if you want to do it this way, is, well, what if you made your triangle with the y-axis? Now, generally, if you read the textbook, they don't make the triangles with the y-axis. They always go with the x-axis. But if you did it with the y-axis, yeah, actually, yeah, it kind of throws things off a little bit. But in that case, well, even then, the y value would still be negative. And then this one would, so yeah, if you want to call this theta or something like that. But I wouldn't really recommend doing it this way. Yes, I'm not sure. It could be a difference in how it was done in your section. But yeah, I always draw a line to the origin and then a line going directly to the x-axis. And that will fit. Now the y coordinate was given, so we can label, the y direction with the y coordinate. And then the x coordinate is not given. And then the one I haven't answered yet is, how did we know the other one was 1? Well, we were told that this point is on the unit circle. So if you were to draw the unit circle and this point is on that circle, the unit circle starts at the origin. And so since this line segment that we've just drawn is to the origin, it must have length 1 because it's on the circle. And so this is a radius of the circle. All right. So now we can use the Pythagorean theorem to find the missing coordinate. Is that all right there?
It makes a bit of sense, but I'm still so confused on some parts, but it's okay.
Okay. Yeah, I guess you could even go in this direction. Check this out, because, well, we could actually even bypass that, because we don't even, yeah, here's something else, is we don't even need the drawing in a sense. We can skip it, because we know that an x coordinate is missing, a y coordinate is given, and then since we're told that we're on the unit circle in the problem there, it says on the unit circle, then automatically r, the radius value of the unit circle, is 1. So we can go straight to the Pythagorean theorem. X squared plus y squared equals r squared. X is unknown, y is given, and r is 1. And so we can solve this equation here. Oops, I didn't square that. So we can solve this, x squared plus 5 over 16 equals 1 squared we know is 1, which we can write as 16 over 16 to get a common denominator with the other fraction. We subtract 5/16 on both sides. And so we get x squared equals 11 over 16. Take the square root of both sides. And so we get x is equal to plus or minus the square root of 11 over the square root of 16. And so, do you know which of these values we want to keep, the positive or the negative? Excuse me, values.
The negative,
Why the negative one?
because we're in quadrant 3 and both
Yes.
x and y negative.
Yes. So notice we actually didn't really even need the drawing. The drawing is essentially more of a reference, and then yeah, we're in quadrant 3, which means it goes to the left, and that means we need the negative value. Yeah, but really you can even figure that out without the drawing as well. Yeah, so notice, yeah, with everything I did here, started from here. Yeah, we technically didn't need that drawing. Since we're on the unit circle, I did want to draw it just so we can see that the radius value is equal to 1, but as long as you just say, okay, r is equal to 1, since we're on the unit circle, that's good enough as well. All right, so hopefully that helps. Connor, did you have another question that you'd like to ask?
Do you mind going over like one of the questions from number 9?
Sure. Yeah. Which one? We did one earlier. We did A. So if you want to do a different one, we can. Well, we
Yeah.
can do A. Pick one.
Can we do 9C?
9C. Sure.
Yeah, I believe we haven't done that one in class. I don't think so.
Okay. Okay. Yeah. Yeah. I did different problems for different classes. I don't remember which one we did. So whichever one we want, we can do. So 9C. All right, now we'll just zoom in a little. So it says a 22-foot ladder is leaning against the side of a building. So here's our building. And then here's a ladder. If the ladder touches the building at a height of 20 feet, what is the angle of elevation that the ladder makes with the ground? So here's the ground. So we'll assume that this is a 90-degree angle here. This height here was given to be 20 feet. The ladder length is 22 feet. So yeah, part of this is, drawing this correctly. Yesterday as I was, walking around, I did see some people draw this incorrectly. So, yeah, is this drawing, does it seem to match up with what the problem says?
Were you asking me?
Yeah, I mean,
Oh, yeah.
yeah, I guess yeah, so hopefully, yeah, maybe I should have just asked you which, how to draw it, but yeah, this is how we would draw it. And then it says, what is the angle of elevation that the ladder makes with the ground? So we want this angle here labeled theta. Another thing that some students were doing incorrectly was they were trying to find this angle here. Because it said, what is the angle of elevation? And they thought, oh, the elevation, the elevated angle or something, the one up high or something. I'm not sure what made them think that. But yeah, make sure it says with the ground. So we were looking for that angle theta. So what trig function can we use that relates this angle with those two sides?
So since we have the hypotenuse and we have the opposite angle, it would be sine.
Sine. The
Yes.
sine of theta is equal to opposite over hypotenuse. Yes, we can use this. Now it's actually easier. Well, because let me continue here. The sine of theta, if we reduce by 2, we would get 10 over 11. Do you know what 10 divided by 11 is off the top of your head?
No.
No, yeah, and I don't either. I mean, so one thing to notice is that if you use the cosecant of theta, that would be not opposite over hypotenuse, but hypotenuse over opposite. And if you reduce that, you get 11 over 10. Do you know what 11 divided by 10 is off the top of your head?
Would it be 1 with a remainder?
Yeah. 1 with the remainder, or as a decimal, we could actually just write it as 1.1. Right? Because we would just move the decimal place over 1 place to the left when dividing by 10. And so it becomes 1.1. And even, you know, if we had to do long division, that's fine too. You can do long division and figure that out. Yeah, so this one is easier to divide, you know, that one's 1.1. This one here, you know, a little bit harder to divide. It can be done as well. But notice now we have the cosecant of the angle that we're looking for is 1.1. So we go to the chart and check to see if there is a cosecant that has an angle of 1.1. Is there an angle that has a cosecant of 1.1?
Yeah, it'd be 65.
Yeah, 65 has a cosecant of 1.1. But it turns out that 68.2 also has a cosecant of 1.1. And this has to do with the fact that these are approximate values. So the cosecant of both of these angles is actually not the same, but approximately, yeah, they're you know, very close to each other. So either one of these answers, if you showed this work, let's say you were taking a quiz in my class and you know there's a problem like this, you would get marked correct for either of these two. Theta equals 65 degrees, or theta equals 68.2. Now, one of these was given in the answer sheet, 65 degrees, rather than 68.2. And we can actually find that other one if we wanted to do the sign, you know, the way that we, so, you know, that's the end of the problem there. We did it. It was 65 degrees or 68.2. This one gave us two different answers. This method, but there's nothing wrong with this method. It's more with the approximations in the table. Since there are approximate values, we're getting two possible answers. But if we do this problem a different way using the sign, then you'll see that there's actually only one solution. And so we'll have to do a little bit of long division. 11 goes into 10, 0 times. So we put a 0 there and bring that down. 11 goes into 100, 9 times, oops, 9 times to get 99. When we subtract, we get 1. Bring down a 0 to get 0. 11 goes into 10, 0 times. 0 times 11 is 0. This is, bring down another 0. 11 goes into 100, 9 times. And so we get here the sine of theta is equal to approximately 0.909. And so we go back to the chart and look for is there an angle who has a sine of approximately 0.909?
65.
Yeah, so notice that that one only gives us, narrows down. This one here is close to 0.909, but not as close. So we would choose the closest of those two, which is 65 degrees. So yeah. So this tells us theta equals 65 degrees. Now, yeah, so unfortunately, due to the approximations on the table, yeah, it kind of seemed like we had to do a lot of work there. But yeah, both of these methods are correct. Yeah, so does that make sense? You know, or yeah, does that make sense there?
Yeah.
Okay.
But so the reason why, or like from my understanding, like the reason why we're using like theta and like the angle of elevation, where we don't have to redraw the triangle like in the dotted line, is because we're looking at the angle of elevation, right?
Yes,
So
yes.
like, we would only use we would draw like the second half, like what you've done in the previous problem, if we're looking at the angle of depression, right?
Yeah, if you're looking at the angle of depression and the angle that you're referring to is not on the diagram that you've drawn. Yeah, so the angle of elevation, when I drew the picture, it was just automatically like in that triangle, that first triangle that I drew. Whereas if you go to this problem here, usually the triangle that's drawn is you would draw, okay, well, the building, the distance from the accident, and then the next natural line to draw is this one here, the line of sight from the person to the accident. And notice this drawing here does not contain our angle of depression, at least the way that the angle of depression is defined. It's defined to be the angle from the horizontal, and so this angle here, and so that's why we have to draw that other one, because in the initial triangle that we drew, the angle of depression isn't really there. There is another 35-degree angle that Dolfo mentioned earlier. I don't think he's here anymore. But without knowing that those two are equal, yeah, the angle is not really in there. And so that's why then we draw the angle of depression by drawing the horizontal and then the depression, the downward swing of the head there. Yeah, so that's why I drew that second triangle, because the angle that we're referring to, 35 degrees, is not in the original, that blue triangle. Does that make sense?
Yeah, makes sense. Thank you.
Yeah, because if I drew this and then said, oh yeah, as Dolfo mentioned, which is 100% correct, but then if I just said, oh, use this angle, I know a lot of people would say, whoa, wait a minute, how do we know that's 35 degrees? And that's from geometry. There's a property that says in geometry that says that those two are equal, but I'm sure a lot of people forgot that property. So that's why I just draw it there in yellow. Because yeah, that's how the angle of depression is defined in the textbook.
Okay. Thank you, Professor.
Yes, you're welcome. All right, we can go back around to Anais if you have a question.
Can you explain how to find for 8C?
8C?
Yeah.
Okay.
Just how to find the A.
A. Okay,
Yeah.
sure. Yeah, so what is A? With respect to this angle that's known, this 35-degree angle, which side is A?
Adjacent?
It's adjacent, yeah. So we have adjacent and we have hypotenuse. So with just the 35-degree angle, we have the option of using cosine. So Katoa tells us cosine is adjacent over hypotenuse. That could be used. And actually, that would be the best one to use. So let's try that. Cosine of 35 degrees is equal to adjacent over hypotenuse. So A over 9, we can multiply by 9 on both sides. And so we get 9 times the cosine of 35. Cosine of 35 is equal to 0.8, looks like. 0.80 or whatever. That's the same as 0.8. And so this gives us 7.2 is equal to 8. All right, so does that make sense there?
Yes. I don't know why I was using sine.
Ah, yeah. So if you use sine, then that would find you B, the length of B.
Oh, okay. Oh, okay. I think that makes sense.
Less sine of what angle?
Sorry?
Yeah, you were using sine. You were using sine of what angle?
35.
35. Okay, so that would be incorrect because the sine of 35 is opposite over hypotenuse. And so notice that that points at B. And so,
Yeah.
yeah, since you asked about A. Now,
Oh, all right.
if you had used angle B, then you could use sine. Sine is opposite over hypotenuse. But
Oh,
yeah, but you said you were using 35, so yeah, so yeah, there's a lot of ways to do this problem. So you could use sine if you use the angle B, because that now it is A side length A is opposite of angle B.
okay. Makes sense. Thank you.
Yeah. You're welcome. All right. Ashley or not Ashley? Do you have a question?
No, I'm good for now.
Okay. All right. And let's see. We'll go back to Christian. Did you have another question you'd like to ask?
Let me see. I had a question on 4F.
4F.
Mm-hmm.
All right. 4F. Yes. Okay, that was good. That was nice. Given an angle in standard position, find the coordinates of the associated point on the unit circle in exact form. Okay. So this was kind of nice actually, because we could actually do this one without really doing much calculation. There's a couple ways to do it. Bless you.
Thank you.
There's a couple ways to do it, but yeah, so, and do you have any preference for how to do this problem, or is there a specific way?
No.
Okay. So, yeah, let's go ahead and take a look at yeah, this way that I'm thinking here. And this works because this is a nice number, like -5 pi. Do you know how many degrees pi is? Pi radians?
180.
Yes. So if we want -5 pi, then we can start here at, let me erase this X. We can start here at 0 degrees and go this direction clockwise. That would put us at -pi. And then if we rotate clockwise again, that would take us to -2 pi. And then if we just continue to rotate, this is now -3 pi and -4 pi. And -5 pi is right here. So -5 pi is actually just, let me draw, is actually just, oops, -2 pi, -4 pi, and then -5 pi. It's right here. And so what angle, if we end up right here, the terminating side is right here, and the initial side is right here, what angle is that on the unit circle?
What angle is 2 pi?
No, what angle is coterminal with -5 pi? Based on our drawing there, it's just a straight angle. It opens at 0 and it terminates in the opposite direction. Go to the unit circle. It starts right here and terminates in this direction. That's coterminal with pi radians, or 180 degrees. And once you figure that out, that's the associated point right there.
It should be on the corner over there.
You hear me? Yeah, so okay, so yeah, the based on our drawing, -5 pi is coterminal with pi radians, and the associated point is -1 comma 0. Okay, so that's one way to do this problem. Does that make sense there?
To me, not really.
Okay. Yeah, so we can do it a different way as well. Let me see, I'm trying to find where I did that. What the? Okay. Oh yeah, right there. Okay, so another way that I mentioned earlier, were you here? I think you were here earlier when we did this one here, the -300.
Yes.
Yeah, so we added 360 because -300 is not in the interval from 0 degrees to 360 degrees. We added a full rotation to get 60 degrees, which is inside of this interval from 0 to 60. From 0 to 360. 60 is in between 0 and 360. So we'll do a similar thing here. Then we can say, okay, well, negative 5 pi, is that between 0 and 2 pi? No, because negative 5 pi is negative, it's less than 0. So what we can do is we can add 360 degrees or 2 pi radians to get a coterminal angle. And so that is going to add to negative 3 pi. And negative 3 pi is also not between 0 and 2 pi because it's negative. So we can add 2 pi again. And when we do that, we get negative 1 pi. This is still not between 0 and 2 pi. So we can add 2 pi one more time. And 2 pi minus 1 pi is 1 pi. And notice now we get pi, which is on the unit circle. It's between 0 and 2 pi. And so the associated point, if you go and look at the unit circle, is the one with coordinates negative 1 comma 0. That one is associated with pi. So the answer is negative 1 comma 0. Okay, so there's a second way of doing this problem. How's that?
It was a better explanation. It was easier to understand.
Okay. All right. Yeah. So yeah. Cool. Yeah. Yeah. Either one of those works. Yeah. So yeah. It's just like if I told you essentially what we're being told. There's even another way to do it, but yeah. I mean, if that one kind of made sense there, then that'd be good enough. But if I told you to, let's just say I tell you to graph theta equals 750 degrees. Do you know where 750 degrees is?
I'm not sure. No.
Yeah, no, okay, that's okay. Yeah, so we can. That's a very large number. It's larger than 360 degrees. So we could subtract 360 degrees to get 400. Oh, sorry, 390 degrees. And this is still outside of 360, 0 to 360, so we could subtract 360 again and to get 30 degrees. So 750 degrees is coterminal with 30 degrees. And since we had to subtract 362 times, that means it is a 30-degree angle, and then 2 more rotations around the unit, around the circle, around the two more rotations. So here is a 30-degree angle, just right there. But 750 degrees is not just that little rotation there. It's going to be a full circle, 360 degrees, plus another 360 degrees, plus 30 degrees. That rotation there represents, in green, represents 750 degrees. Notice it ends up at the same spot. It terminates at the same spot that a 30-degree angle does. But it's a lot more rotation. Okay, so there's that's a similar idea to what we just did on part F. It's just in part F, it's in radians, so it might be a little bit harder to understand because most people are not as familiar with radians as they are with degrees. And Christian, I'm curious what your major is.
Oh, my major is psychology.
Psychology. Okay, cool. Yeah, so you know, I was just curious because you know, if you're in science and engineering, then you would have to take like a lot more math and yeah, I think with a psychology major you don't have to take that much more math. Is that right?
Yeah.
Okay. Yeah, yeah. So I was just curious because I was gonna say yeah, these if you're like say you said you were engineering major, I would say yeah, you're gonna see a lot of radians and stuff in calculus, calculus 1, 2, 3, and you know all of those. And so it would be very good to study up on those so that you have a good foundation. But I mean not that you shouldn't study anyways, but yeah, eventually you'll finish your math classes, and then maybe you can some people might want to forget about this stuff afterwards.
And I was wondering, where did the value 750 come from?
I just made that one up. I just made that one up as an example
Mhm.
because I wanted to do one in degrees, since the part F was in radians. Yeah, so that had nothing to do with the problem. Yeah, we finished the problem over here when we boxed this associated point. I just wanted to do one in degrees, and I was trying to say that's a similar idea. This one here, 750 degrees, has a lot of rotation in the positive direction, meaning in the counterclockwise direction, whereas this one here that we did negative 5 pi, that has a lot of rotation in the clockwise direction, in the negative direction. Yeah, but I wanted to do a similar problem in degrees because the one that you asked for was in radians, which sometimes the radians by themselves can kind of throw people off because we're just not familiar with radians as much. And that's why I commented on the whole what your major was because if you said you were an engineering major, I was going to say, yeah, you got to get very comfortable with radians because they'll come back up in your next few classes. But yeah, but all right, yeah, thank you, Anais. I'll see you tomorrow. Yeah, okay, so that was just an example I made up.
Okay.
All right. Let's see. I was recording. I'm going to stop the recording.